Exercise 7.2 Problem 16 discussion. From the top of a tower of height 60 meters, the angle of depression of the top and the bottom of a building are observed to be 30 degrees and 60 degrees respectively. Find the height of the building. Okay, it's an interesting problem. We have a tower and we have building. Okay, so from the top of the tower, which is a height 60 meters, they are observing the top and the bottom of the building. And they found it, since they are observing this is angle of depression, it means the building is shorter. Okay, the height of the building is less than the height of the tower because it's angle of depression. He has to look down, right? So that is one key point we need to note down. So depression, right, are 30 degrees and 60 degrees. So from the tower, they look at the top of the building and bottom of the building. They find the angle of depression to be 30 degrees and 60 degrees. And we are asked to find the height of the building. Okay, let's draw a simple diagram. So this is the tower. This is the building. A person is here, observes the point P, that is the top of the building. So join that line. Okay, and from here again he observes the bottom of the building. Join that line. And they say the angle of depression. Angle of depression is what? The line between the line of vision and the horizontal line, or the eye level. So this is your eye level and this is the line of vision. So this is 30 degrees. Similarly, this is the line of vision and this is the horizontal line means. So this whole thing is 60 degrees. Okay, right. So since this is 60 degrees, we know, and this line are parallel. This is the ground level. Okay, so what happens? This will be equal to this. That is, this will be equal to this angle. Alternate angles in the case of parallel lines. So this whole angle is 60 degrees here. Similarly, this line and this line, you're drawing a line parallel to this, hitting this tower line. Okay, so these two lines are parallel. So this angle will be equal to this angle, 30 degrees. So this total height is given as 60 meters, and we are asked to find the height of the building. Right, so let's think through what happens when you use tan 60 opposite by adjacent. So which means we can calculate this distance. Okay, and or even before that, we know the height of the tower. We want to find height of the building. If you can find this distance CD, height of the tower minus CD is the height of the building. Okay, because DE equal to BAB. Am I right? So that's what we need to calculate. So we need to calculate CD. So to do CD, how will you calculate CD? Using tan 30. Tan 30 is CD by dB. But the problem is, in this equation, tan 30 is CD by dB. We don't know both CD as well as dB. So it is difficult to calculate. So we'll have to calculate dB, then from which you can calculate CD. But how will you calculate dB? dB is also equal to AE. Right? But in this relationship, tan 60, which is opposite CE divided by AE, you will be able to calculate AE, right? Because tan 60 is 60 divided by AE, and you know the value of tan 60 and you can calculate AE. Once you know AE and dB are both equal. So use tan 30 equal to CD by dB and you will be able to calculate CD. Okay, so this is approximately the problem will be worked out. So let's list what's given in the problem. What's given in the problem? Height of the tower is given 60 meters. Angle of depressions are given 30 degrees and 60 degrees. What are we asked to calculate? We are asked to calculate height of the building. So what is the formula? As usual, tan theta is opposite by adjacent. Okay, because this is the vertical opposite. These are the two angles which is given. Okay, angle of elevation, sorry, angle of depression. But we have converted into angle of elevation. Okay, now these two angles are given and we need a relationship between the vertical side and the horizontal side, and that is typically tan theta. Step 1, as usual, draw a rough diagram, label and mark the diagram with given values. In triangle AEC, substitute the value of theta in triangle A, E and C. Okay, substitute the angle of theta. What is theta? Theta is 60 degrees. So tan 60 is opposite by adjacent, that is CE divided by EE. Okay, in this tan 60 is known and CE we know. Okay, So that is 60 meters, so from which AE can be calculated. And what is AE? AE is also BD. Am I right? So now go to the next triangle, B, C and D. Again apply tan theta. Tan theta is opposite by adjacent, that is CD by BD. But BD equal to AE, so which means that is we know AE value, which means we know BE. So we know this value, we know this value, which means CD can be calculated. So once you know CD, then it is very easy to calculate DE, because this whole distance, which is 60 meters, minus this will give you DE. And what is DE? DE is equal to AB, which is the height of the building. Okay, so let's write that. So substitute the value of CE and CD. What is C? We know the relationship CD plus DE equal to CE. We just calculated CD in step 3. And we know DE, we know CE, which is given as 60 meters. So substitute the value of CD and CE in this equation, you will be able to calculate DE, right? Because these two are known, so from which DE can be calculated. But again, as I said, what is DE? DE equal to AB, which is the height of the building. Okay, so that is how this problem can be solved. So what I suggest is pause the video here and try to work this problem on your own, and on completion please come back and check your working against our solution. The solution. So let AB and CE represent the building. Let AB, okay, and CE represent the building and the tower. So this is the building, this is the tower. Height of the tower is given 60 meters. And join this line, right? From here you are observing the top of the tower, and from here you are observing the bottom of the tower, and that is the angle of depression. This is the eye level, so this is a line of vision. So this is angle of depression 30 degrees, and this is the line of vision for the bottom of the building, and this is your eye level. So this whole angle is 60 degrees. And since these two lines are parallel, so which means this angle and this angle are alternate angles, are equal. Similarly, these two lines are parallel, so this forms the Z, inverted Z. So this total angle equal to this angle, so 60 degrees. Now consider A, C and E, triangle ACE. Tan 60 will be equal to opposite, that is CE divided by AE. That is what is given here. And what is tan 60? Tan 60 is root 3. So CE is 60. So 60 by AE will be equal to root 3, or AE will be 60 by root 3. Multiply both the numerator and denominator by root 3. You will get 60 root 3 by 3. And 3 will go 20 times, so it becomes 20 root 3. So AE is 20 root 3, or BD is also 20 root 3. As these two distances are equal, or lengths are equal. Now, consider triangle B, C and D. Tan 30 is opposite by hypotenuse. So, tan 30 is opposite is CD, okay, divided by BD. So, in this triangle, tan 30 will be CD by BD. Tan 30 is 1 by root 3, or CD by BD will be equal to 1 by root 3. CD divided by BD is, we just calculated, right? We calculated AE in the previous triangle, but AE and BD are equal. So this relationship will become, or equation will become, CD divided by AE, which is 20 root 3, will be equal to 1 by root 3. Right? So this CD will be 20 root 3 by 3. So this root 3 and root 3 will get cancelled, and we will get CD as 20 meters. So once that is known, DE can be easily calculated. DE, we know, what is DE? CE minus CD, okay, or CD plus DE equal to CE. From that you can calculate DE is CE minus CD. That's what is given here. So DE equal to CE minus CD. CE we know, which is given in the problem, 60 meters. CD is, just now we calculated as 20 meters. So DE is 40 meters. But what is DE? DE is basically AB, right? both are equal. And what is AB? AB is the height of the building. Thus, the height of the building is 40 meters. Okay. So, I hope I made it clear. If not, please go through this video one more time. It will become clear. Okay. Thanks for watching this video.